So the last video of 3.3 got cut off before I realized, so let's finish up that problem we were working on. We were right around this point where we had the two equations we now need to solve for. 6 equals z minus 3 and z plus 6 equals negative 2z plus 3. So start here on this first equation, add 3 to both sides, because that will give us, the 3's will cancel out and that will give us the z by itself. So doing that, adding the 3's to both sides, you should end up getting 9 equals z, or z equals 9, as the 3's would cancel each other out here. 6 plus 3 is 9. For the other equation, we have a little more work to do. We have to first get the z's on the same side, our like terms. We can do that by adding 2z to both sides to cancel out the 2z's on the right hand side here. So doing that will cancel these out. And then over here we have to add a single z plus 2z, giving us 3z. So we have 3z, bring down the 6, bring down that 3. We then need to get the non-z terms to the other side. So the 6, we need to subtract a 6 to get rid of this positive 6. So subtract 6 from both sides, canceling out the 6's over here. And that leaves us with 3z equals negative 3 when we do 3 minus 6, giving us negative 3 there. Last step, to get z completely by itself, we need to divide by the coefficient 3. So dividing by 3 on both sides divides out the 3's here, gets us z by itself, and negative 3 divided by 3 gives you negative 1. So for this example, I had to come all the way down here for it. Our two possible answers for z, kind of write this over here. Our z could either be 9 or z could be negative 1. Okay, either or. And again, like we did up above where we looked at, we could take either of those two numbers, plug them back into this equation for z on both sides, and you're going to get something over here that equals the same thing you have over here. Okay. So now looking at our last two examples, we have the absolute value of 5r minus 3 equals negative 4. It's kind of a little tricky. Everything else we've looked at, we had absolute values equaling a positive, something that was positive. Like up here we had it equaling a positive 7. Here it equaled a positive 7. Even in our example it was a positive 17. If you remember what I said before about absolute value is describing a distance from 0. And I said that's for that reason it always has to be positive. You can never have an absolute value of something that will result in equaling a negative number, like we have right here. An absolute value, when you take an absolute value, it can never be negative. Okay. Okay, an absolute value can never equal a negative. And so for that reason, since we have that situation, what possible answers are there? What possible solutions? None. There are no solutions. If you again recall, we use the null set, that 0 with a line through it. Pretty much means the same thing as saying nothing. There is no number we could plug in for r that would give us something inside that absolute value that would then give us that would then be equal to negative 4. It could have been equal to a positive 4, then we could have split it into two equations like we did up here. But because it's equal to a negative 4, nothing we can do. And then the last kind of special case here, what if you have an absolute value set equal to 0? Okay, 0 is not negative, so that's alright. We can have an absolute value equaling 0. Again, as long as it's not negative, that's okay. But it's not going to be like these cases up top here where we split it into a positive equals a positive 7 or a negative 7. You don't have a positive 0 and a negative 0. You just have one kind of 0, and that's 0. So instead of splitting this into two equations, when you have it set equal to 0, all you do is set your equation equal to 0, drop the absolute value bars, and then you have to just solve that equation. So subtracting 5 from both sides of this equation, we would get x by itself, and 0 minus 5 would give us negative 5. Going back and checking, negative 5 plus 5 is 0. The absolute value of 0 is like saying how far is 0 from 0? Well, it's 0 units from itself. And that is all for section 3.3.